The diameters of ball bearings produced at a factory are approximately normally distributed. Suppose that the mean diameter is 1.002 centimeters and the standard deviation is 0.006 centimeters. The product specifications require that the diameter of each ball bearing be between 0.980 and 1.020 centimeters. So let's write down our mean and standard deviation. So our mean is 1.002 centimeters and our standard deviation is 0.006 centimeters. We want to know what proportion of ball bearings can be expected to have a diameter under 1.020 centimeters. We're looking for the probability that x is less than 1.020. So that's what we're trying to find. So we're going to put in our mean in StatCrunch, 1.002, and our standard deviation of 0.006, and we want less than, so less than or equal to 1.020, and we're going to hit compute. So this is approximately 0.9987. And now we want to know over 1.020. So what we can do is do 1 minus 0.9987, which is one way to get our answer. Right, so complements. We already have that answer previously. Or let's do it in StatCrunch to get used to it. So the probability that x is now greater than 1.020. So we're going to change this to greater than or equal to. So we get approximately 0.0013. So our next set of problems. So we have that what proportion of ball bearings can be expected to have a diameter between those two amounts there, which is the ball bearings that can be expected to meet the specifications, right? So we're going to go to between, so we want probability that x is between those two values. So probability that 0.980 is less than x is less than 1.020. So I'm going to change these here, our given values, and hit compute here. So this is approximately 9985. Right? And we want to know now what's the probability that it will be over 1 centimeter. So this is the probability that x is greater than 1. Go back to standard, and we want greater than or equal to plain old 1. This is going to be approximately 0.6306. Now we want under 0.995. So less than 0.995. So less than or equal to 0.995 and compute. 1217 here. So now we're looking at percentile ranks. So we want to know what is the percentile rank. So now we're looking for the area or the probability. Right? For a ball bearing that has this. So 0.991 is below the mean, so just a rough sketch. And then our area here. this value is 0.991. So what is the probability that x is less than or equal to 0.991? So that's what we're looking for here. So we're going to change this to 0.991 and compute, and we get approximately 0.0334, right? If I multiply this by 100, that gives me 3.34, so we're looking at approximately the 3rd percentile. Right? And again, same kind of idea, percentile rank again, of 1.011 centimeters. So the probability that x is less than or equal to 1.011. So we're going to change our value here. So 1.011 and compute. So this is approximately equal to 0.933. So if I multiply by 100, we get 93.32, which is approximately the 93rd percentile. And 2 more parts. We want to determine the 10th percentile. So a little bit different. Now we're looking for the x value, right? So we want to know the x value. So this is our area this time. So a rough sketch here. So our 10th percentile, somewhere down here, we're trying to find x. Okay, so we know this area here is 0.1. Right? So the probability that x is less than or equal to some value equals 0.1. And then we have our mean and our standard deviation. So less than or equal to, we don't know this value, but we know that our area should be 0.1. So compute. We get approximately 0.994. So our 10th percentile here is 0.994 centimeters. And then we want to determine the diameter of the ball bearings that make up the middle 99%. Right? So rough sketch here again. We're looking at x's. 99 is our shaded region in the middle here. We're trying to determine 2 x values. Right? So the probability of it being between 2 values, and that should be 0.99. So we're going to come over to between. Our mean is still the same, standard deviation is the same. We don't know these 2 x values, but we know we want the between area to be 0.99. So we're going to type that in and hit compute. So these are 0.987 centimeters and 1.018 centimeters approximately. So those are our diameters of the ball bearings that make up the middle 99% of all the diameters.